There are a number of vector operations that we might want to be able to accomplish. In this clip, we'll just talk about two that we've sort of hinted at already. One is finding the magnitude. And the second is finding the direction of a vector. And obviously for both of those, there's a sort of trivial version of them in the graphical space and a less trivial in the sort of component space. So if we think graphically about finding what the magnitude of a vector is, well, we just measure the length. So the magnitude of the vector A is how long it is. And if we think graphically about finding the direction, we look at what the direction is that A is pointing, that the vector A is pointing, and we say, well, if we take a vector of length 1 in that direction, that would be the unit vector A hat in that direction. From a component perspective, the sort of key here is mostly using Pythagorean theorem. And so long as we've got an orthogonal coordinate system, and I'll make a little warning here, we are using orthogonal coordinate systems right now. We are not going to be using them throughout the class, so you really need to be a little bit careful about this. But so long as you have an orthogonal coordinate system, which means that the sort of the basis vectors, the different directions that you're interested in, are all at right angles to each other. So the sort of Cartesian coordinate system is a classic example of an orthogonal coordinate system. I say you have x coming out of the page, y going to the right, and z going up. X is perpendicular to y and z, y is perpendicular to x and z, and so on. So in an orthogonal coordinate system, you're able to simply take the components, square them, add them together, and take the square root following the Pythagorean theorem. So if I have some vector, a vector that's 3 times I hat plus 4 times j hat plus 1 times k hat, right, which means I move 3 in the x direction, 4 in the y direction, and 1 in the z direction. The magnitude of that vector would simply be the square root of the x component squared, so 9, plus the y component squared, 16, plus the z component squared, 1, or radical 26. And if I want to find the direction, so that's how I figure out what the magnitude of a vector is in an orthogonal coordinate system. To find what the direction of a vector is in a coordinate system, all I have to do is simply take the vector itself, right, and divide the vector by its magnitude. So let me cross that out. So I got ahead of myself. So I take the vector, divide the vector by its magnitude, and so in this particular case, I would take 3i hat plus 4j hat plus 1k hat, all divided by the magnitude of the vector, square root of 3 squared plus 4 squared plus 1 squared, which is in turn 3 over square root of 26i hat, 4 over 26j hat, 1 over 26k hat. Of course, all those 26's are square roots.